Welcome to Podcast Learn and Fun. Let's start today's journey of learning.
Okay, sounds good.
Have you ever heard of the idea that a single thing can be in multiple states at the same time?
Yeah.
It sounds crazy, right?
Yeah.
But that's what happens in the quantum world, thanks to something called quantum coherence.
Yeah, that's a great way to put it. Imagine like a coin spinning in the air. It's not heads or tails. It's this blurry mix of both until it finally lands.
Oh, I see.
And it's kind of like that, except instead of heads and tails, we're talking about the fundamental properties of particles, like electrons or photons.
So these particles are in this hazy state of maybe this, maybe that. Like they haven't quite made up their minds, huh?
Exactly. And this haziness is captured by the concept of superposition, right? It's not that the particle is changing rapidly between states, it's genuinely in both states at the same time. And the degree to which these states can coexist peacefully, like well-choreographed dancers, that's what we call coherence.
Okay, so it's like this delicate dance of possibilities. But how does this coherence actually connect to the idea of superposition? Still trying to wrap my head around that.
Okay, think of it this way. For a particle to be in a superposition, the different parts of its wave, those maybes, need to be in sync. That synchronization is coherence. It's what allows the particle to maintain this counterintuitive state of being in multiple possibilities at once.
So coherence is like the glue that holds this mind-bending superposition together.
Yeah.
Without it, the whole thing falls apart.
Precisely. And here's where it gets even more fascinating. In the quantum world, we describe these maybes using something called wavefunctions. Think of it as like a mathematical recipe that tells us the probabilities of finding the particle in different states, you know?
Okay.
And a key ingredient in this recipe is the concept of phase.
Phase, like phases of the moon.
Not quite, but it's a good analogy. Just like the moon goes through different phases, waves have phases too. It's essentially where the wave is in its cycle, right? In quantum mechanics, the phase relationships between different parts of a wave function are crucial for maintaining coherence.
So it's not just about the maybes, but about how those maybes are synchronized. Their phases have to be aligned for coherence to exist.
Exactly. It's like an orchestra playing in harmony. If the instruments are out of tune or the musicians aren't playing in sync, the music falls apart, right?
Yeah.
Similarly, if the phases of the wave function are misaligned, coherence is lost and the quantum magic kind of fades away.
So it's like this carefully orchestrated symphony of quantum possibilities, with coherence as the conductor keeping everything in sync.
That's a beautiful way to put it. And it's important to note that coherence is not just some abstract theoretical concept. It has tangible consequences in the real world.
So what? How does this quantum coherence actually show up in experiments or technologies?
Well, one of the most famous examples is the double-slit experiment. It's a classic experiment that demonstrates the wave-like nature of particles, right? And it shows the role of coherence in creating interference patterns.
I think I've heard of the double-slit experiment. It's the one where particles act like waves and go through two slits at the same time.
Yes. And the fascinating thing is, if the particle is coherent, meaning its wave function is nicely synchronized, it creates this distinct interference pattern on the screen behind the slits. It's as if the particle is interfering with itself.
Wow.
But if coherence is lost, this interference pattern disappears, and we just see, a more classical-like distribution of particles.
So coherence is what makes those particles act like waves and create those crazy interference patterns.
Yes.
But I've also heard of something called decoherence, right? Does that mess things up?
Decoherence is, it's the party pooper of the quantum world.
So what exactly happens during decoherence, and why is it such a big deal?
Imagine, you're trying to balance a spinning top on a table. Any slight vibration or bump from the environment can make the top wobble and eventually fall. Similarly, in the quantum world, interactions with the environment can disrupt the delicate balance of coherence.
So decoherence is like the environment bumping into our carefully balanced quantum system and knocking it off kilter.
Precisely. These interactions cause the phases of the wave function to become scrambled. It leads to a loss of coherence. It's like the musicians in our orchestra suddenly losing their synchronization. It turns a harmonious symphony into a cacophony of noise.
So in essence, decoherence is the process of a quantum system losing its quantumness and behaving more like a classical system.
Exactly. It's a constant battle between coherence and decoherence in the quantum world. And this battle has profound implications, especially when we try to build quantum computers.
Quantum computers. How does coherence play a role in those?
Quantum computers rely on the principles of superposition and coherence to perform calculations that are impossible for classical computers. They use qubits, which are like the quantum versions of bits in a classical computer, you see.
Right.
A qubit can be in a superposition of 0 and 1 simultaneously, but if decoherence sets in, the qubit loses its quantum advantage, and we're back to square one.
So decoherence is like a qubit's worst nightmare, turning it from a quantum superhero into an ordinary bit.
Exactly.
Okay.
But why is decoherence such a big deal for quantum computers?
Yeah, why?
Well, for quantum computers to function correctly, we need to maintain coherence in those qubits for as long as possible. Otherwise, errors accumulate and the computation becomes unreliable. It's like trying to build a sandcastle on a windy beach, you know?
Yeah.
The environment keeps messing things up.
So coherence is like this precious resource that we need to protect if we want to harness the power of quantum technology.
Yes.
It makes you wonder what happens when we have multiple particles interacting. Does coherence still play a role then?
Absolutely. When you have multiple particles, things get even more interesting. Instead of just one particle doing its quantum dance, you have a whole ensemble of particles interacting with each other, creating this complex web of quantum correlations.
Okay, so with multiple particles, the quantum dance becomes a complex ballet with many dancers.
Yeah,
I'm guessing that coherence becomes even more difficult to maintain in this scenario.
you got it.
Okay.
In a multi-body system, the environment has even more opportunities to interact with the particles and mess up their coherence. It's like trying to choreograph a ballet in a hurricane. To understand how coherence behaves in this setting, we need to differentiate between two types of correlations: classical and quantum.
Classical and quantum correlations. What's the difference?
Think of classical correlations like a group of dancers following, a set choreography.
Okay.
They are correlated, but their movements are predetermined. Quantum correlations, on the other hand, are more like a group of improvisational dancers, like responding to each other in real time.
Oh.
Their movements are interconnected in a much deeper way, much more mysterious way.
Wow, that's fantastic analogy. So in multi-body systems, coherence is what allows for this like intricate improvisational dance of quantum correlations, right?
Exactly. Coherence is the underlying magic that makes this quantum ballet possible. But remember, the environment is always lurking, ready to introduce decoherence and disrupt the performance.
It's a constant battle between coherence and decoherence in the quantum world. But scientists are constantly developing clever techniques to protect coherence and harness its power for technologies like quantum computing. It's really a fascinating field.
It certainly is. And the more we understand about coherence, the closer we get to unlocking the full potential of quantum technology.
I can't wait to see what the future holds for this field. Okay, so we've covered a lot of ground here, from single particle coherence to the complexities of multi-body systems. It's amazing to think that such a strained and counterintuitive concept lies at the heart of so much cutting-edge science.
It really highlights how quantum mechanics is rewriting our understanding of the universe. It's a journey of discovery that's full of surprises.
Speaking of surprises, I'm curious, how do these ideas about coherence actually play out in real-world applications like quantum computing? I mean, how do we go from these abstract concepts to building actual devices?
That's where things get really exciting. In quantum computing, we use qubits, which are like the quantum versions of bits in a classical computer. And guess what? Coherence is crucial for these qubits to work their magic.
So those qubits need to be in a coherent state to perform those mind-bending quantum computations.
You're getting it.
Okay.
A qubit can be in a superposition of states, like that electron we talked about earlier. It can be a 0 and a 1 at the same time. But for this to work, we need to maintain coherence. Otherwise, our qubit turns into an ordinary bit, and we lose all the advantages of quantum computation.
So decoherence is like a qubit's worst nightmare, turning it from a quantum superhero into a mere mortal bit. But how do we actually control these qubits and make them do something useful? I've heard of these things called quantum gates, but I'm not sure how they fit into the picture.
Quantum gates are the building blocks of quantum circuits, and they rely heavily on maintaining coherence. Imagine a quantum gate as a special operation that manipulates the state of our qubit while preserving its coherence, right?
Oh.
It's like a delicate dance move that changes the qubit's state without disrupting its quantum harmony.
So a quantum gate is like a choreographer for our qubit, guiding its movements while ensuring it stays in sync with the quantum rhythm.
Precisely. But here's the catch. If coherence is lost during the operation of a quantum gate, the computation can go haywire, leading to errors. It's like our qubit dancer tripping over their own feet and ruining the entire performance.
So maintaining coherence is absolutely essential for quantum computers to work reliably. It's a delicate balancing act that requires incredibly precise control over these qubits.
It's one of the biggest challenges in building scalable quantum computers. Researchers are developing all sorts of clever techniques to protect qubits from decoherence, like using special materials, designing fault-tolerant circuits, and even using quantum error correction codes.
It sounds like a constant race against decoherence, but it's amazing to see how much progress has been made in this field. Quantum computing is truly a testament to human ingenuity and our ability to push the boundaries of what's possible.
It really is, and the potential applications are simply mind-blowing, from revolutionizing drug discovery and material science to breaking encryption codes that were once thought to be unbreakable.
Quantum computing has the potential to change the world as we know it. But I'm curious, is coherence only important for quantum computing, or are there other fields where it plays a crucial role?
Coherence is a fundamental concept in quantum mechanics, so its influence extends far beyond quantum computing. For example, in quantum optics, which deals with the interaction of light and matter at the quantum level, coherence is key.
I've heard of lasers, which are based on the principles of quantum optics. Do they rely on coherence as well?
Absolutely. Lasers emit light that is highly coherent, meaning the photons in the laser beam are all in sync, marching in step like a perfectly disciplined army.
Wow.
This coherence is what gives lasers their unique properties, such as their ability to focus light into incredibly tight beams and generate intense power.
So coherence is what makes lasers such powerful tools, from reading information on CDs to performing delicate eye surgery. It's amazing to think that this strange quantum concept is behind such everyday technologies.
It's a reminder that quantum mechanics is not just some abstract theory. It's the foundation of many technologies that we rely on daily.
It makes you wonder what other hidden wonders of quantum mechanics are just waiting to be discovered and harnessed for future technologies. It feels like we're only scratching the surface.
Indeed, the exploration of the quantum world is an ongoing adventure, full of surprises and endless possibilities. Who knows what other mind-blowing applications we'll find for coherence in the years to come?
It's exciting to think about all the potential out there. And speaking of exploring further, could you tell me a bit more about how coherence plays a role in cryptography? I know it's a field focused on secure communication, but I'm not sure how quantum mechanics fits in.
It's fascinating how coherence is the key to a revolutionary technology known as quantum key distribution. Imagine you want to send a secret message to a friend, but you're worried that someone might intercept it.
That's a concern we all have in this digital age. So how does quantum key distribution help?
With quantum key distribution, you can use the principles of quantum mechanics, including coherence, to create a secret key that's impossible to copy or eavesdrop on without being detected.
Wait, so it's like having an unbreakable code thanks to the power of quantum mechanics. Tell me more.
Exactly. The key is encoded in the quantum states of particles, like photons. And here's where coherence comes in. If someone tries to intercept those photons and measure their states, they'll inevitably disrupt the coherence, leaving behind telltale signs that the key has been compromised.
So it's like having a built-in alarm system that alerts you if someone's trying to peek at your secret messages. That's incredible. It seems like a very elegant solution.
It is. Quantum key distribution is a prime example of how coherence is not just a theoretical concept, but a powerful tool that can revolutionize fields like cryptography and secure communication.
This is also fascinating. It really highlights the interconnectedness of the universe, from the quantum realm to the macroscopic world of human communication.
It does. And this interconnectedness is even more apparent when we consider the role of coherence in the biological systems that surround us.
Biological systems, you mean like plants and animals?
Mhm.
I thought coherence was mainly a physics thing.
It might seem surprising, but there's growing evidence that coherence may play a role in some of the most fundamental processes of life.
Really? Like what? Give me an example.
For instance, some scientists believe that coherence might be involved in photosynthesis, the process by which plants convert sunlight into energy.
Photosynthesis. That's how plants make their food, right?
Mm.
Are you saying there's There's quantum weirdness going on inside plants.
It's a possibility. There's research suggesting that coherence might help plants transfer energy more efficiently during photosynthesis. It's still an active area of research, but it's a fascinating example of how coherence might be influencing the world around us in ways we're just beginning to understand.
So those plants might be harnessing the power of quantum mechanics to fuel their growth. That's incredible.
It is quite remarkable. It's a reminder that the quantum world is full of mysteries, and its influence extends far beyond the realm of physics.
Absolutely. So much is still unknown, and we have much to discover and explore. Where do you see the future of coherence research heading? What are some of the biggest challenges and most exciting possibilities on the horizon?
That's a great question. One of the biggest challenges, as we've discussed, is combating decoherence. It's the arch nemesis of coherence, constantly threatening to disrupt our carefully crafted quantum systems.
So the battle against decoherence is ongoing, with scientists constantly seeking new ways to shield those delicate quantum states.
Exactly. Researchers are exploring a variety of approaches, from developing new materials that are less susceptible to environmental noise, to designing clever error correction codes that can compensate for the inevitable disruptions.
It's like a constant arms race between coherence and decoherence, with scientists wielding their ingenuity to protect those precious quantum states.
Indeed. And as we make progress in this battle, we unlock new possibilities for quantum technologies. Imagine quantum computers that can operate for longer periods, tackling even more complex problems.
It's like giving those quantum computers more stamina, allowing them to run those intricate quantum algorithms without getting tripped up by decoherence.
Yeah.
It would be amazing to see those quantum computers reach their full potential. And who knows what other applications we might find for coherence as we continue to explore this quantum world.
Yeah, the possibilities they're endless. It's like opening a Pandora's box of quantum possibilities with coherence as the key. Coherence is not just a scientific concept. It's a gateway to a world of technological advancements that could transform our lives in profound ways.
It is exciting to think that we're just at the beginning of this quantum journey with so much more to discover and explore.
Yeah, it's a journey that requires a blend of scientific curiosity, technological innovation, and a willingness to embrace the strange and wonderful world of quantum mechanics.
Absolutely. This deep dive into quantum coherence has been truly eye-opening. We've explored its role in superposition, interference, decoherence, quantum computing, cryptography, and even biology.
It's a concept that touches upon so many different aspects of science and technology, and its importance just continues to grow as we delve deeper into the quantum realm.
I'm so glad we had the chance to explore this together. It's incredible to think that such a subtle and often overlooked concept like coherence plays such a central role in shaping the universe as we know it.
It really speaks to the power of fundamental research and the importance of staying curious about the world around us.
Well said. Thank you for listening to Podcast Learn and Fun. You like our videos? Please subscribe, click the like button, comment, and share. See you next time.